Hi folks, we're back with another video on how to use OLI Flowsheet. What we have here is the neutral one case that we created in a previous video. And we want to show you how to use controllers. But I first want to talk about a deficiency, in my own opinion, of the neutralizer block. The problem with the neutralizer block is if it fails to converge, for example, if we have the pH spec in the wrong region, the block just stops and you don't really understand what's going on without doing a lot more work to figure out the error. A much more robust, although albeit a longer process time, is to replace this with a controller algorithm. So the first thing we're going to do is we're going to actually save this as a new name, because I have a file that works. My own personal workflow is that I don't ever modify a file that is currently working. I am going to save it as a new name. So File, Save As. I have some files there. I'm actually just going to rename this file Neutral 2. And now I'm going to do things you should not do unless you've saved your file. I'm actually going to delete the neutralizer. The outlet stream is gone, but the inlet streams are still here. I'm going to replace this with a new separator, and I'm going to connect the liquid stream to it. I'm going to create a new outlet stream, the liquid stream here. I'm going to rename it, also to call it neutralized liquid. Okay, but I'm going to change this guy. Okay. I'm going to add a block called a manipulator. A manipulator block, down here, is nothing more than a multiplier block. We're going to go ahead and move this out of the way. We don't need it at the moment. The manipulator block is a multiplier. What comes in gets multiplied by a value, and that comes out. We're going to put the caustic stream into that block. We'll clean things up a little bit here. And I'm going to add yet another stream from the outlet of the manipulate block into the feed. I don't actually need to rename that feed because it's not really that important to us at the moment. But actually we will. Actually, I'll take that back. We'll call this adjusted caustic. And again, we can move things out of the way. I'm now going to add a controller. This is actually a feedback controller here. And now I'm going to add some controller lines. I still want the neutralized liquid stream to be a pH of 9. So when you use the controller connections, when you do that, the red dots become live, and I can connect it to my controller. I'm going to just give a little more arrow there, and now I'm going to take the output of the controller into my manipulate block. So the program is going to sense the pH of the neutralized liquid. It's going to see how far it is from the set point. If it's far away, it's going to tell the manipulator to do a multiplication. We'll make this a little clearer where it's supposed to be, and adjust the flow. So let's put some targets in. We're going to control the pH of this stream. The pH will be 9, just like it was in the previous example. Now the control block, manipulate 1, oops, let's go back to the control block. We're going to adjust its total factor flow. I always save before I run, and I am going to run it. It should run fairly quickly. And it's actually run. So things have changed a little bit. Okay, this was a very high number of about 277. It's back to the original value. Okay. I now want to do a little bit more advanced technique. I am going to copy the call out. I'm going to click on adjusted caustic, and paste the call out. That way I don't have to do a lot of editing. I can once again also copy the call out, and let's do neutralized liquid and paste it as well. So you notice that the pH isn't exactly 9. That's because there's some tolerance. And I want to look down here in the output window. I want to make this a little bit bigger to go through to show you what the program actually was doing. It initially calculated the inlet streams. That was base waste, acid waste, and caustic. Okay, then it stepped through the mixer, the separator, and got to separator 2 and determined its pH. The original pH computed in the stream neutralized liquid was 1.8, which is very far from 9. So it made some adjustments. And it's actually going through here and changing the flow factor to make it bigger as necessary. And eventually it gets up to a pH of 9, but there is some tolerance here. And you can see that the value seems to be in the 4th decimal place. pH probes aren't usually that accurate, so this value is essentially 9. Okay. All right, we're going to do something a little bit different here. We're going to clean up the process a little bit. This use of a manipulate block is a little bit archaic because it adds one more block to the calculation. We can control the flow rate of the caustic stream directly. And I just want you to note that the caustic stream currently is 101.77. The adjusted caustic stream is 277, 247. So what I'm going to do is I'm actually going to delete the manipulate block. This gets rid of its associated downstream. So we're going to reconnect this back to it. And we're going to add a controller line from the outlet of our feedback loop directly into the stream. If I go to the feedback block here now, you notice that it's now connected to a stream, not a block. So there's the stream name. However, I do have to tell its parameter. I'm going to do its actual flow here. I am going to save this as a new name because I had one that worked. So I'm going to call this neutral 2B. And I'm going to run it. And it converges very quickly. And you notice that the adjusted caustic is actually back to the 277 value it was before. So we have the manipulator block built into the calculation inside the stream. The pH is exactly the same as it was before. This allows us to get a little bit cleaner calculation order. I don't have a stray block. That doesn't seem to do much. Also, the mass balance report looks cleaner here. We don't have a stray block that we have to worry about. So, and that's it for this particular one. We'll go add recycles and so forth to a later video. Thank you.